Good afternoon. After lunch, it's always a hard one, right? So, first show of hands, who enjoyed himself the last day and a half? Was it worth it? Yeah? Okay. I hope you're going to say the same thing once I'm finished. Enter the Matrix. The Matrix, for those who hasn't seen that movie, who has been not living the IT life, as we should be. Oh, okay. So the Matrix is imminent. It's everywhere. We're all plugged in, as we know. And it's a vivid thing. Yes. We love vivid things, but we're not aware that there's more behind that. And we do know that in the world of the Matrix, we have this city called Zion, which is under constant attack, right? And these things are attacking from the outside. We call them squiddies, or whatever you want to call them. Just call them ugly, and they come in many, many forms and many, many, many numbers. I'm starting to sound like that guy from Police Academy, with many, many good things to come. But not only the attacks come from the outside, also from the inside, like Agent Smith, Mr. Anderson, you know. So they have their defenses at Zion. They are well prepared, but still the war is at hand. We all know that. And with all these defenses at hand, they think we're pretty safe, but still they are waiting for this one guy. The one, Neo. The information that I'm going to give you today is going to make me hope that you're going to think about when you design Azure applications, and that you take into account all the security measures that are at hand for your Matrix applications, namely your Azure environment. And finally, you want to become like Neo. You want to become the one. So this is a session which we want to make you aware of all the security features that we have in Azure and avoid system failure, aka as known as being attacked, hacked, or at least have a countermeasure for that. So that was a small introduction. Let me just tell something about myself. I'm Mike Martin. I'm also from Belgium. I'm sorry, you already had two. They did an excellent job. I hope I can just follow in their tracks. I'm also one of the Belgian Azure user group leads, together with Martin. I don't know where he is. And Sam was also part of that, but he gave on the torch to a younger candidate. What I mainly do in my daily life is just talk about Azure to customers and help them make the correct decisions. So a little bit, where is he? Where's Carl? Where's Carl? A little bit like you, sir. We help them make the same decisions and do the correct decisions. So if you want to follow me on Twitter, do be advised, it's a big data stream. And I do mean in volume. Sometimes in velocity, but mostly in volume. Okay? For those who don't know the 3 V's for big data, look it up. There's going to be a lot of slides in here. Yeah. I also have some demos, don't worry, no panic. But the slides are especially there for you as a guidance afterwards, so that way you can tag it along and use it as some reference materials. Although we all know that Microsoft Azure is a living thing and that it gets updated on a regular basis. Okay. So enough about me. Let's talk about Azure for a little second. We all know that Azure is a vast, enormous beast already. It has outgrown since 2008 to the 38 regions that we know today, with locations now also available in the Netherlands, the UK, Germany. We have Korea on the map somewhere, if I'm not mistaken. We have more regions coming. So taking this into account, we open up our environment more globally. So that's also something we need to take into account too. Yeah. This is just a reference slide, as I mentioned. Also, next to that, we are aware that Azure is huge. I mean, who remembers the first version of Azure? The very first version. Do you remember the first portal? It was like one thing that was on there. And then we had version 2, and then we had version 3, and this is already iteration 5 or 6, if I'm not mistaken. But the number of services has been growing, and if we design applications We're not just going to go with one piece. We're going to glue them together. We're going to make them work together. And we have to keep into account that, well, there's things that we want to, encapsulate. We want to have boundaries on there. We don't want our VMs wide open, although that Azure has a lot of security measures already built into it. Okay, so I'm mainly going to talk about a couple of these. It's hard to cover everything. I try to, and I failed miserably. I can do that, but then we'll be here next week, Sunday evening, 7 o'clock somewhere. And then we probably have had every single little aspect. So, yes, will I be able to answer all your questions today? We'll see. So if you have any, just raise your hands, or whatever you want, and we'll make it happen. Oh, can you get me a glass of water, please? Okay, I forgot to bring one. Cool. So there's a lot of things in there. There's out-of-the-box things that are related to security, but also things that are not visible. I'm going to touch them a little bit here and there. Okay. So the Azure control plane, the Azure security plane, is actually built up out of a couple of blocks. Actually 15 different blocks, as you can see. Mostly when I talk to customers, yeah, have you taken into account security? The first thing that comes to mind is, oh, yeah, that's only Azure AD, right? That's security, right? It's AD. Wrong. It's more than that. Yeah. It starts already with where you want to deploy your services. Is your company allowed to deploy in a country? Yeah. Are you bound to some compliance rules, governance rules? Those are things that you also need to keep in mind. That's also a part of Azure security. I know it's a lot. Oh, thank you. Thank you. That will make me more comfortable. Sorry about that. But it also comes down to auditing. Who's doing what? Segmentation, how you design for multi-tenancy, these things, right? Even how Microsoft responds to things like incident response, but also you guys. What is your log retention? All those things you need to keep into account. A couple of things is something where you cannot handle, I mean, like physical security. Well, we don't have direct access to the Azure data centers. Although if you can visit them, you should. It's a nice trip. Yeah, it's really, really worth it. Ask Sam, Martin, and me, and we'll talk afterwards. So these are all the things that are building up the Azure security landscape. Okay, so keep that in mind. Now, the matrix, the outside, the big bad world where attackers are coming from, and everything else. Yeah. Inside we have the physical defenses. Yeah, this is what I call the Azure security onion. Yeah. This is something I invented myself. It's not an official term, but I think it's like an ogre thing. Layers, onions, right? It's an ogre thing. You know. Okay, too early? All right, sorry. So we have the physical defenses. We have the sharks with freaking lasers, and nobody can get past those. Yeah. Some get them as a present. Only Batman can do that because he has shark repellent bat spray. Yeah. So he can kill the bats. Yeah. The sharks, I mean. So if you've ever seen the 1966 Batman movie, that's a reference to that one. So the physical defenses we also have the edge defenses. I'm going to go talking a little bit about the edge defenses that Azure has and provides with you. So that's our big mech warriors standing at Zion. And then we have your defenses, yeah, the things that you need to take care of in your applications, meaning the pieces of Azure that you can make even stronger secured than they are already secured. Yeah? And then you have, last but not least, yes, your code. And this is where it all starts. Because if you write insecure code, basically you're already, screwed. Yeah? You're already hanging. And this is where most of the companies go wrong, because that's something they tend to forget. They don't do a secure development lifecycle. Who heard about SDL before? One guy. All right. Who knows that Microsoft provides tooling for that, for SDL? Who knows that? One guy. All right. Are you using it? In the project. So you're doing threat modeling. Okay. So yesterday Sam talked about Azure IoT, which is also something which we need to secure because we need to secure our devices, we need to secure our endpoints, we need to secure our gateways, we need to make sure that we cover the correct certificates and all that stuff, and then we need to harden our service bus or event hubs, whatever you need, right? Well, for those things, all these little things can be modeled into something we call a thread model, and we can pass every single, and we have like a checklist where we can check off whether we're doing it okay, yes or no. Now that tooling, which we have, is free downloadable. I'm just gonna show you a small sample. Here we are. I'm just right. That looks okay. I'm just gonna do it like this. Just gonna switch. So if this is bad for the recording, I'm sorry. So we have here a small sample, and what we can do here is we can put in all the pieces that are tangible for connecting. This is just a mock-up. I mean, there's a lot more samples. Like you have a sample there already out of the box. Come on, just open it up again. Here it is. So if you just open it out of the box, there's this sample that you can use. What it does, it generates some generic application with all the connections, where it's HTTPS. And on all the properties, you can actually take a look and deeper dive look on what's happening there. You can actually set, well, say, well, what do you want to do? Is it secure? Is the source authenticated? What does it transmit? Is it pure JSON REST and all of that? Yeah. And in the end, if you're done modeling, and you have all your different pieces of your application, you just generate a report, and that way you can see what is prone and where you need to take what you need to take into account. So if I just go to reports here, and I create a full report, generate it. It should open me well, I'm just going to put this where all my important data is going on my desktop. So demo Igloo. If all goes well, it should open it. And here we go. It will generate me a report with a status of everything which has been started or not, and what kind of things are prone. Now, this is based upon something we call the stride model. On which you can read a little bit about it. It's spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Those are the things that you need to keep in mind. So if you're designing your application, these are all the things that could go possibly wrong. There's of course more. If it comes down to hardware and stuff, you need to harden that too, right? But this can help you actually prepare a checklist for your application. So this can be found. I will put the links are at the end of my slide deck, so you can download. This can be found at microsoft.com/security/SDL, where you can immediately find the page, find all the information how this works, and also the way you can use that in your applications. So that's a good thing. All right. So I hope I've already taught you something today which was worthwhile knowing. Good. All right. So back to the presentation. Where's my escape? So let's talk a little bit about trust. Well, first of all, if you're doing Azure, we all know these models, right? But this one is the pizza thing or the taxi thing or whatever you persiflage have you seen on it. But this is more on where the responsibility lies when you're doing Azure projects. I mean, we all know that when we're doing on-premise, old-school server move, pizza box moving things, we actually are responsible for everything, going from the physical security with keys, biometrics, whatever you have, over to the networking, all the OZ layers and that stuff, and then till the end, till the application again, right? When we're doing cloud, whether it's public or private, and by the way, and that has nothing to do with shielding your environment, according to me, but it has more to do with the economics model. You can easily have a private cloud in a public cloud model and vice versa, but that's another discussion. But depending on the model that you choose, you also have different responsibilities. Like, for instance, if you're doing IaaS, so real servers, virtual machines, you're responsible up until the operating system. You need to patch. You need to harden the operating system. You need to make sure that the privileges that you have are not running as all a system account, for instance. Bad. Yeah? From a PaaS perspective, you know that if you give your users the wrong access, they can screw up your entire application. They can configure things that you don't want them to be. They can deploy things that you don't want them to deploy. And when it comes down to SaaS, well, most of the responsibility lies with the vendor. So there's shared responsibility, and that's also something that you need to keep in mind. Oh. Okay. So when it comes down to, Microsoft securing your environment, Microsoft is constantly attacking their own. They're testing Azure. Yeah. And they have two teams for that. The blue team and the red team. I found this appropriate, right? It's not like they're on drugs. I mean, some of the products might look like they've taken something, but no offense, Microsoft people. But SharePoint, for instance, or Silverlight. But the thing is that they actually are constantly testing themselves. And what is the responsibility of these teams? Well, the red team are the attackers. They're constantly doing their thing. And what they do is they try to force that breach assumption is a given. They try to prove it. Based upon all the tests that they're doing, so in this case, security monitoring gaps that are found, incident response, leverage of compromised accounts, all these things, well, they need to prove it, that they can actually do it. Yeah. The role of the blue team actually is trying to counter all the actions, gain intelligence of what is happening and how they can counter it and improve the operations. Yeah. As I told you, there's going to be a lot of slides, so I'm not going to go over every single point here, but you get the idea. They're constantly doing this. If you want to penetrate your own environments in Azure, you want to pen test, you need to ask for an approval first. Just write out a form and they'll work with you on the penetration testing of your applications. You cannot just do it like that, because then it could be that you are seen as a real attacker. And you know, that could cause some troubles, right? Okay. They're working on some trusted cloud principles. Security is one, privacy and controls another one, compliance and transparency. Well, just for your reading. But as I already said, assume breach, right? So make sure that you understand this well. If you assume breach, you're already halfway there, because then you know that you're constantly under attack. And this is a generic thing. This is something we kind of forgot over the years, and we see it coming back. So make sure that you get this. So secure lifecycle, secure development lifecycle is already halfway there. Operational security is the other half. Yeah, if you put these two together, it's a good thing. Microsoft does this by doing bug bounties, war game exercises with blue and red teams, and so on and so on. Another thing that they do is provide you in physical security. As I told you, the layers, this is the physical one. They have, as I mentioned, the data centers are huge, and they are only operated by a couple of people, 8 to be tops. 4 of them are cleaning. There's one security guy. There's another one watching the other 6, and the other 7, and 2 guys that constantly ramble about with a chariot with hard drives. Because Microsoft, they order them by the ton. They don't longer order them by the numbers. They order them by the ton. That many disks are being destroyed every year. Yeah. Fences, barriers, biometrics, and so on and so on. As you can see, even if you're running around here, you cannot physically access the racks. Basically it. So that's a good thing. But as Azure is a multi-tenancy environment, they also have to foresee in that. So, sorry about that. So they run their own version of Windows. And we see that come back now as Nano, a little bit. So all these things that we see now in the future, Windows Server 2016, they've been running that for years, yeah, in their own data centers. That's why, I think it was Satya who said it, Windows Server 2016 was born out of the cloud. That's true, because they've been using it and dogfooding it for years. Now, I'm not a server lover, but there's proof that this is a more secure operating system, right? They try to segregate it, so that way everybody can just fiddle with their own software without interacting with anybody else. They try to make sure that nobody can access underneath the other VMs or the other services that are running for another tenant. Right? That's basically in a nutshell. So everything is segregated, everything is being foreseen as a multi-tenant environment. Yeah. As I mentioned, segregation goes on to a level. It's the same principles for multi-tenancy. You get SQL isolation, storage account isolation by meanings of SAS tokens, which are generic for you, and you create your own private keys, things like that. So these are the designs that they have in mind. When it comes down to secure operations, well, there's already a lot of countermeasures being done for you when it comes down to protecting the Azure environment. We have, first of all, the network access layer, on which we have intrusion detection systems, scanning of malicious code which is passing over the riot. And there's also firewalls that are protecting the entire system. They have DDoS countermeasures, and from there out, you're entering Azure itself. Once you're there, you have your VMs or your services which are also running host firewalls, like for your VMs, for instance, but you can implement your own. I mean, there's a lot of third-party vendors that are now publishing their appliances into the cloud as a capable VM solution. A little bit on patching. Well, Microsoft patches a lot for you. Wasn't me. Microsoft patches the underlying systems. I mean, if you are doing VMs, now I'm talking VMs again, but if you're doing VMs, sometimes you get, in the past, when you were running single instance VMs, you get these mails for like, your machine will go down because of patching, right? Who remembers those? If you ever run VMs? No? Okay. At least one guy. But that doesn't mean that they're patching your VM. The only VMs that they're really patching are cloud services. And of course the other systems that you are using, like Service Bus and all these things, right? Because they all run on some kind of computing. And like serverless computing, there's always a server somewhere, but it's not exposed for you, right? That's gonna go like a running gag over the weeks. But the thing is that you need to apply patch management to your applications and VMs internally, but for cloud service, for instance, they do it for you. So they follow a strict schedule there, and if there's a exploit or really malicious code error or something that can really bring you down, they will act to it, right? And they test it, even after the events that happened last year. How does the DDoS protection work? Well, they, if anything happens, and if your domains will be attacked from an Azure perspective, like AzureWebsites.net, well, they actually put in a system that your ISP also can do. So they try to do rerouting, and they do that on a different address, so that way your application will stay up. So it's a little bit like a traffic manager, but then without the hassle of setting up a traffic manager, but purely for DDoS. As you can see, they also do support for a couple of attack profiles, TCP sync, and flooding of TCP and UDP. So you're already good for that, but that doesn't mean that you cannot provide your own countermeasures by means of firewalling with custom domain names. When it comes down to that other part of security, which is the little bugs that are pestering us, they also have large-scale scanning of malicious code going on. As I said, they do a lot of dog fooding. A lot of the applications that we're seeing today, which I will demonstrate shortly, also are being used by them. They use larger scales, in-front protection, System Center endpoint protection, managed by System Center, and so on and so on. Yeah. That doesn't mean that you do not have to install any antivirus. I mean, we have been having antivirus on cloud services. We have been having antivirus on, as an extension on VMs. Use them, even if it is just the anti-malware provided by Microsoft itself. And if you want to go that extra step for antivirus, just go for ATP, which is a Defender security center that you can actually monitor all your VMs and your desktop PCs. So that way you can have, once an attack is happening, and it's executing malicious code, you actually can see a full trace where it's coming from. I'll demonstrate something with System Center later, which is also a measure that using some kind of these things. Cool thing is that if you're doing anti-malware protection, most of the vendors that we have today can just plug into your VMs. And they can monitor it from like the same way like you're doing your own VM monitoring today. Well, and everything can be extracted to SIEM. Threat protection, it's a little bit the same. DDoS. Network isolation, from both a client perspective and from a networking stack perspective. Your VMs, for instance, are totally not connected. And there's no trust between the hypervisor and the VMs. So there's no networking bound there. Although they run on the same networking stack, but they're totally isolated. That's because of the thing that they have created with Server 2016, also with shielded VMs. You just cannot access them. They're bound, right? And that's why we need to set endpoints. In the past, we had endpoints on containers for cloud services. Nowadays, we can do that with NSGs and with ACLs that we can create, and even some routing if we want that. I'll discuss that later on in a more detail. Monitoring. A couple of things that that Azure is monitoring. First of all the service statuses. The service pages, right? You can put that on your dashboard and you can see all the flags popping up green on the map. Most of the time it's not in 100% real time, but yeah, it works. And they're monitoring the entire environment. They're monitoring the fabric controllers, they're monitoring the hypervisors, they're monitoring everything which is underneath, right? And on the security events that are happening there. Yeah. But you still need to monitor your own devices. You still need to monitor your own services. As Martin yesterday showed you application insights. Yeah. And did anybody else talk about OMS yesterday? Yeah, I think Alexander did, right? I think so. Can't remember now. These are the tools that you need, and with Monitor you can now expose everything to one screen, so you can build your own dashboards. I'll show you some demos in just a second. We're almost through the very slow part here. Also, when they're doing management on your environment, and if they ever need to take some pieces for them to, you know, take a look at the issues that you're having, even Microsoft personnel is needed to do multi-factor authentication. So nobody just uses a user and a password. They all use an authenticator. For those of you who are using Azure Active Directory today, show your hands. So for those who are using Azure Active Directory, and even just like live services, use one of these as your authenticator. There's an authenticator app which can now be used for AAD and live services, or OneDrive and those things, Outlook.com, which is actually the same application. And you just need to approve or give in the PIN code, and that way you can actually make sure that you have secure access. You can do this by using domain principals and so on and so on. This is, again, a design that you need to make for your applications. So why store your own users and passwords inside a database if you can use a system which is proven, right? Whether it's a Facebook, a LinkedIn, or even an AAD account. And Microsoft uses the same principles here. Threat protection. This is more on the auditing part and what's going on your system. And this is an older slide, but these things are also today in Monitor. I'll show you in a second. We're going to go over the transparency. Yeah, the thing that I want to talk to you about here is that you decide where you put your data. Yeah. And also you decide on when your data is leaving your region. If you're doing geo-replication, you decide where you want to move your data. Yeah. Microsoft will not move the data for you. You need to set up your geo-replication. You need to choose your storage replication, whether you want it read access or not. And for those who don't know that, you can actually have 4 types of replication of storage. You have local, you have zone, you have geo and geo read access, right, for those who do storage. Yeah? But you decide on where you want to replicate, just like SQL Server. They can also, SQL Server databases in Azure, they can also be replicated to a different region. But you decide on when and how, not Microsoft. Yeah? And they don't have access to your data. If you're doing an incident, you open up a ticket at Microsoft. Microsoft will contact you, even if you do a new trial, for instance. They also contact you. Yes, sir, as we saw that you have a new trial. How's that experience coming? I just activated it. Yeah, yeah, but we want to know. We want to make sure that you know what you're doing. We want to give you a head start. But if you get called by Microsoft when you have an incident, a ticket that you have opened, and they need to access their resources, the PCs that they're using are being segregated from everything else on the network. They need approval by at least 2 managers. And then they get just enough admin rights and just in time admin rights on that machine. So they only have because most of the time they call you after 2 hours or after 3 hours, and then they say, yeah, now we have to stop. Well, the reason why they have to stop is because they only have access for 2 hours or 3 hours, depending on the case that they're working on. So if somebody else has to work on the case, it's documented and they get access to that afterwards by just the same means of access control. So that's important for you to know too. When it comes down to data, all your data is being transferred in an encrypted layer. Yeah. That doesn't mean that your data automatically gets encrypted at the endpoint. Like storage, it's an option to encrypt at rest. It's luckily existing now, but it didn't exist for a long time. Now we're finally there. So you have the choice to, if you're doing communication, you have the choice to do HTTPS instead of plain old HTTP, and depending on what you want to design for, you can have other options too. Yeah, but that's something also very nice. So as I mentioned, also encryption at rest. Boot disks and data disks on VMs or cloud services can now be encrypted by using BitLocker. SQL Server has transparent data and column level encryption, so TDE. I'm going to go into that a little bit later. Shares, storage is all being enabled now. You also can have Store Simple, for those who know that device, which is just a bunch of disks in an appliance. And you can also virtualize it. It can also be encrypted with... sorry?
Can you explain more about that application encryption stuff?
Yeah, these are APIs that you can call. This is something that you need to do. If you're doing channeling, or if you're putting files somewhere, in the past you still need to encrypt your own files and you needed to decrypt them. There's always a good thing to do to still do that, but now the accounts can have encryption out of the box. So that way you don't have to do that anymore. There's also, if you're doing sharing of information, there's also rights management, which is also using the same principles, but that's also something that you need to imply yourself. That comes with the Azure Active Directory, but that's something that you need to implicate yourself and execute yourself. Okay. Another part of security is compliance. I'm just going to show one slide on that. Most boring part, but Microsoft is compliant with most of the certificates. And they have PCI HIPAA. They also have now DoD. They're the first cloud provider that's fully DoD compliant. So that means the U.S. military can fully use or abuse Azure. So if now I'm not going to say it because today is already inauguration day, so I'm not going to say it. Sorry, too easy, too soon. But they can actually provide you all the certificates, and these can be found, and all this information can legally be found in the Trust Center. So that's a site on the Azure homepage, which we call ACOM, Azure.com, which is dedicated to all this matter. So if you have any questions legally, is my application compliant enough? Of course, you need to keep those rules in mind too. If you're doing a SOX application, then you put everything wide open that your administrators and your users can just put money on my bank account. Hey, I'm happy with that, by the way, but then it's still your call. But the system itself is compliant enough to make sure that if they ever get an audit by or an issue by SOX or by Basel or something, they can prove that, well, we don't have that data, but we can prove where it is and how to use it. And then you have court law orders and so on and so on. Important enough for you to know is that when it comes down to data destruction, there's data deletion, and you have about 24 hours for a storage account before it gets overwritten, but also when you delete a subscription, you can still have up to 90 days to recuperate some of the data. Knowing that when it comes down to real storage, the disks are being handled by a certified company which actually fully shreds the disks. Okay. Now, enough about the tier. Now, where do we find all the security mechanisms for you? Because this is important enough for you, but what can you do? Well, let's start by authenticating and accessing Azure. Yeah? Most of us used live IDs in the past. Why? Well, it's a given. It's easy. For those who know what happens when you create a subscription, it actually creates an Azure Active Directory for you, and your live ID becomes a part of it. Right? For those who don't know that, take a look at some basic videos. Right? You can go to manage.windowsazure.com or just portal.azure.com, right? And basically, when you create one, you're already a service administrator and you own the damn place. Well, or a co-administrator, and you can actually, in the past, which is no longer the truth, but those who are still using ASM, you could also use certificates. Well, these management certificates can be self-signed. They don't check for certification expiration, but they can also be used by things like the APIs and PowerShell. Right? Storage access, well, it uses a secret. Well, these are the things that you can use. It's a primary and secondary. Yeah. And you can have direct RDP access. Right? So those are the things that are basically being used. But try to avoid live IDs. Try to integrate your organizational accounts. Yeah. Implement RBAC, like my dear friend yesterday explained, right? Role-based access control, and this is based on the GI principle, just enough admin rights. Try to narrow it down as much as possible. Another thing, maybe that's a steep curve that I'm taking here, but management certificates are evil. Why is that, do you think? Anybody care to answer that? Nobody? If I get you a management certificate, just pick it out of the box, I can do whatever I want. I get full access. You don't want that. You really don't want me on your environment, really. Even as an Azure expert, you don't want me on your environment. No, but they are evil, so try to avoid them at all costs. Sometimes you need those things. In the past, we had Azure Automation, and we needed to use those. Now we can use service principles, which we can relate to. But try to avoid them. Storage access. If I got your key, I got the secret. You get that song? Well, even last week, Troy Hunt sent out a tweet saying we have data on so many applications that we parsed and decrypted and decompiled. And guess what? Lots of keys in there. Even on GitHub. Take a look. There's storage keys and stuff. the things that you can find there is amazing, pretty amazing. But if you need storage keys, and if you're doing storage, try to use SAS tokens at least. And if you really want to use a key, put them in key vault and make them recycle it, and write a mechanism that recycles the keys every, say, 24 hours, for instance. Because if they have access to your storage account, they have access to your blobs, they have access to your queues, tables, and files. And you don't want that. Huh? Most of the time, it's customer data that's in there, so you don't want that. When it comes down to VM access, virtual machine access, when really IaaS, don't go direct. Go from the inside. Do RDP access from the inside. Harden your virtual network if you using it as a private extension to your network. If not, set up a virtual access gateway, an RDP gateway with Server 2016 or 2012, and let all the access tunnel through that one. So that at least you have a gateway which handles all the traffic, and you also have an overview of who's connecting. And you have less of a hassle of admin connections because you only have 2 connections, right? And try to do it over SSH and PowerShell remoting instead of, because that's a very secure way of doing it. For those who are not aware of PowerShell remoting, it's a little bit like Linux SSH tunneling that you're doing in the same way in responding. And again, all the privileges that you have in Active Directory are being applied there. And the cool thing is that you can do triple hopping. So you need to put in place Kerberos and all those things to make it even more secure.
Alexander showed yesterday.
Yeah, exactly. I didn't see his entire talk, but did he talk about remoting? So you know that then. Now, when it comes down to hardening your networking, well, there's a couple of things that you can do. First of all, you have network security groups. Network security groups are ACL's blacklisting, whitelisting, and ordering of rules. Hard time getting out of my words. Yeah. The orders being put in there are important because denial comes before acceptance and so on and so on. And there's also already a couple of default rules in there, but try to fine-grain them as much as possible. And even you can use this in an automated way to harden your machines even better. If you heard about Azure Security Center, they actually have an API which you can call by means of PowerShell, but you need to do some flying and stunt work to make that accessible. And I'll show a little bit of script in a couple of minutes. And they use ACLs. And in the past, we had ACLs and network security separately. Now they're more integrated, and they couldn't be used together at a certain point in time. Yeah. You can still have inside of the guest OS firewall also some things in there, ACLs on public IPs and so on and so on. And that way you can start designing secure layers, VLANing, DMZs. All these things that we know from our own premises can be designed now through the means of network security groups. So I'm going to go over the role-based access control. Good to know is that you can either do this through Portal or PowerShell. There's a little script here that shows all the definitions for a certain role. Yeah. The PowerShell usage on RBAC isn't that hard. Yeah. It's a very straightforward process. It only needs a little bit of thinking on which roles you want to apply and how deep you want to go there. Key Vault. Now, Key Vault is for securing your secrets and keeping them secretly, and they can be used with anything. They can be used with your application, but also for the things that are already existing today. Nobody says that you can't use Azure Security just for using in Azure. Also in your own premises, if you're running SQL Server in a VM, for instance, you can actually use that to encrypt your databases and have an integration there with your secret. So that way, nobody has your secret, only Key Vault has. So if you change it, it's only the admin that has an initial way of setting it, and everything else goes by later on. So that way, everything stays more secure. A little bit on infrastructure. Important enough to know, there's whoever tried doing a ping to a VM in Azure. It doesn't reply. Why? Because the ICMP is totally blocked. So when it comes down to denial of service and port scanning, only the ports defined by us are open, right? By default, everything was closed in the past. Spoofing, impersonation is not possible, right? So that's a good thing. And even the Hyper-V switching disallows sniffing from the other VMs on the same host. So also, as I already mentioned, VMs are untrusted by the root OS hypervisor. What can be put in there as a security point? Well, we have the endpoints on the containers, and we also have the NSGs, as I already mentioned. Anti-malware extensions, which come in a large choice. Right, we have all the major market leaders, but as I said, if you don't have one of those, use the Defender or the anti-malware by Microsoft. It really, really works. Storage access and BitLocker support on disk is now fully supported. I'm just gonna, as I already mentioned, all these things. Just gonna go over here and have a little. Over to the, yeah. As I mentioned, endpoint ACLs and networks, for those still doing ASM, they don't work together. Also for multi-nicking, network security rules can now be applied to multiple. This is an older slide. I always forget to adapt this one, but they can be used with multiple NICs now. And also, as for standard RDP access, the rest of the access to the internet is being revoked. We also have the Azure Application Gateway, which we can set in front of the web applications or our web interfaces. There's also now coming a Windows Azure firewall, so a web application firewall instead of just a gateway. So this is good for offloading of your SSL and termination and caching, with cooking affinities and routing, yeah? And they can be managed through Azure too, right? Talking about applications, if you want to make sure that your applications are secure, a couple of rules can be applied here. Don't use the default domains that you have. You get them anyway, but use your own custom domain. That avoids scripting easily, script kiddies and so on. Pay attention to REST query injection when it comes down to Azure storage. SQL databases. SQL injection still being a large part of security gaps, right? Try to do auditing. Most of the auditing data is being put in Azure tables, and they can be easily looked at. Use authentication. In the past we had ACS, but now we can use Azure AD, business to business, business to customer, use one of those. Even Windows Identity Foundation or even your own FIM implementation can do the tick. When we talk about data, we also have SQL databases. Today we have encryption in flight, so that's good. We have encrypted channel. We have encryption on the tables, dynamic data masking for those who are using, let's say, very sensitive information. Use data masking on there, so that way nobody can see it. Even if they have access to the database, they cannot read it. Try to implement row-level security if you must. Also, when it comes down to limiting access, we have firewalls based upon the servers or even on the databases. So we have two levels, and you can either manage them through the SSMS. You get a pop-up and you enter your own IP. Do it through the portal, or just do it with the transact statements. And today we also have Azure ID authentication that is possible, right? Even very important there is SQL auditing, because you want to know who has access to your applications anyway. Yeah, okay. Now, I already mentioned Azure Active Directory. that's your control plane for everything, which comes down to your user management from an application perspective or also from a management perspective. Maybe it's time now for a little switch over to something more tangible. So no, this. So if you have Azure, where's my browser? Let's go over to some demos. Is that visible? Make it a little bit bigger. So if we have Azure today, we have all these new toys that we can play with, and one of them is, like, for instance, getting applications into the new portal and making them service principal. So if you want to have secure connections with your applications, this is one of those things that you can do. But the thing that I want to show you, if anybody has access to your application, you have a monitor which you can use to see all the activities that are being done when it comes down to management. I don't know. When it comes down to managing your environment, we have, for instance, I opened up an environment part of Azure, and as you can see, I access the keys of my environment there. So if you want to do a trailing, if you want to have an SLA and even what was I going to say? You want to make sure that your customers have a good overview on what you're doing. This is the way to take a look of who has rights to what. Now, some other things that you can see here is, like, for instance, in OMS, which is also a part of Azure. Where did I put it? The Security Center here. No. Where's my OMS? Yeah, here it is. Oh, come on. It's signed out. All right, let me just. If you want to experience the OMS yourself, if all goes well, should be logging in again. Yeah, it denied me access. Give me a second. Right. Ah, come on. That's what you get when you can't type. I should just bring a secretary for that. I'm just going to show you some nice things we can see. Yep, here we go. Come on, waiting for a response. Come on. Yeah, there we are. Operations Management Suite is, as Martin yesterday already said, it's a log aggregator, and you can have a lot of information there, but it goes more than that. It also manages a part of your backup strategy. It also manages a part of your automation strategy. And you can monitor a lot of things in there. And one of the cool things that you have now is that you have this one solution that you can use when you're running VMs inside of your environment, is a new security in audit environment solution. And it shows you whether your VMs are under attack, for instance. Like, for instance, here we have a really example of a VM that's being under attack and it's being used by a botnet, so that way they can have DDoS attack on the machines and so on and so on. You also have an overview of all the things that are happening inside of your network, like logons with clear passwords, or suspicious activities like logons too many times that are being accessed, and all those things. So this is when it comes down to monitoring, this is one of the tools that you can use. And you can expose all this data back to the Azure Monitor part. Next to that, when it comes down to monitoring, we also have Azure Security Center. And Azure Security Center is actually, where's my VM? Very attentive to the things that are happening inside your VMs, but also for the rest of your environment. You can have policies that you can set either on your resources or on your subscriptions. So that way you can fine-grain your security policies as you want. As you can see here, I put it active on my entire subscription. If I open this one up, You can see all the policies that are being applied. And you can try that, and the good thing is that OMS and Security Center, they come for free for the most part. Even if you're running only 1 or 2 VMs, you can actually use OMS very, very cheap. Yeah? Because it only uses a small amount of data. The OMS is being charged by the amount of data that you put in there and the number of nodes that you are using. So if you have an MSDN, it actually can be used very, 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 very well. So the policies that you can set out of the box are these things. So you have, it does recommendations for you based upon, I'm just going to make it a little bit larger, based upon system updates, operating system vulnerabilities, endpoint protection, and so on and so on and so on. But it goes beyond just the VMs. It also goes into applications, and it also goes into storage and SQL databases. So as you saw, my demo environment is not as secure as it should be. And why did it kill off my entire security center? I only closed that part of the blade. As you can see, once the rules kick in, it actually does the recommendations for you, and it also shows you where the errors are lying. And even it can trigger you alerts, which you can gather from the API, and just make sure that you create a webhook on that and just do something contra to it. Like, for instance, if you have an NSG that is missing on your VM, or you have an attack on your VM, you can actually capture the IP address, create an NSG rule inside of the NSG of your VM, for instance, and make sure that it's hardened that way. Now, I've been playing this morning with some fake virus signatures. You can either use an iCard file or something like that. For those who don't know that, this is just a signature file that you create as a small COM file, and it will be automatically picked up as a virus. I'm just going to demonstrate you what I did here. So I had the VM here standing, and I have this small file here. It was just a text file, and I entered this string. This string can be found on Wikipedia. It's a standard testing string for testing virus application. And when I do that, actually, I save this file. You will see that a file will be created here, and in a couple of seconds it will be removed by my Microsoft anti-malware, because it will be seen as an antiviral signature, as a viral signature. Yeah? That will create a security alert inside of Azure Security Center. As you can see here, anti-malware action was taken, and here are some of the things. It takes a couple of seconds before it's being filled up, but that's how it works. So, and you can actually see, here's my file. There's a DOS iCard test file. We have all the demonstration information, where it was found, what the path was, and all that. So you get all that information. So if you want to have deep dive information on your and deep dive viewing on your security environment, this is the way to do it, right? It goes even further, even recommendations when it comes down to virtual machines, for instance. You can actually see that some of my machines still need system updates, also are missing endpoint protection, and so on and so on. So from there out, you can easily say, I want, if I click my machine, I want to install endpoint protection and just apply it like that. You know, I can just install it from here, and all the actions will be taken for you. And you can see this as a checklist where you can actually use the security center as your first line of defense. Having that said, do we have anything else to say? I think we're almost through here. I think I'm almost out of time. There's only one more thing that I want. Huh? Okay. Just only one more thing that I want to say is that use these links. I will add some extra in there. And I didn't get a chance to thank the sponsors, because they're also important, for this opportunity. I hope you enjoyed the talk. I know there's a lot of ground to cover. I haven't even covered everything yet, but I hope it gives you an idea of where you're going and what you need to do when designing secure applications. Okay? Thank you very much.
So Alan's here. If you